Hi, today I'll be talking about modern human design in the age of AI, a movement that pushes UX beyond a traditional human-centered view and let precision design as something that serves ecosystem, non-human stakeholders and intelligent systems. As AI becomes more autonomous and environmental challenges intensify, UX designers must rethink who and what we design for. Modern human design invites us to see digital systems not only as tools for people, but as part of a larger ecological and technological network. Modern human design represents a paradigm shift in UX. Instead of viewing humans as the sole users or beneficiaries, this approach acknowledges the agency of AI systems, environmental sensors, animals, and ecosystems. It recognizes that digital experiences now happen inside complex networks, where humans are only one part of the interaction loop. Rooted in post-humanist theory, this approach emerged when designers began asking whose voices are missing from our design decisions, who benefits from our interfaces, and who get left out. To make this concrete, the slide outlines three groups: human stakeholders, the traditional focus on UX, then AI agents, which increasingly act autonomously, and then there is environmental system, the ecosystem affected by digital decisions. Modern human design asks us to consider all three of these. Well, the shift toward modern human design didn't happen overnight. This slide shows the evolution over the past few decades. In 1990s to 2000, UX focused almost exclusively on human needs. Technology was designed for people, not with broader system in mind. And then 2010, sustainability entered design discussions, but humans still remain the central decision makers. Next is between 2015 to 2020, AI became mainstream. Designers began questioning what agency does AI have? How do we design for systems that learn, adapt, and make decisions? And then there's until then to present, more than human design, crystallized here ecosystems, AI, and non-human actors are recognized as legitimate stakeholders. This shift moves UX from designing for isolated systems for designing within dynamic ecological and computational systems. Now that we see the history of modern human design, let's see the current trend in UX landscape. It consists of major multi-agent ecosystem where humans, AI systems, and environmental actors collaborate together. The site highlights four major trends nowadays. The first one is symbiotic intelligent system. Interfaces that support collaboration between human intuition and AI computation. Data dominate, both contribute. Second, environmental sensing networks, IoT systems that capture ecological signals like soils, moisture, or air quality and translate them into insight for planning policy. And then next, distributed agency models, design frameworks that acknowledge decision making across humans, algorithms, and environmental systems. Last but not least, ecocentric interaction paradigms. Interfaces designed with planetary well-being as a primary success metric, not an afterthought. Together, these trends show how much UX is no longer confined to screens. It's embedded in the ecosystem. Now, let's dig into the real-world example of modern human design in action. Tech for Nature is a global program created by WWF and Huawei. It uses AI-driven acoustic sensors and camera traps to monitor wildlife populations in places such as Mexico, China, Kenya, and the Swiss Alps. The challenge is that traditional conservation relies on manual surveys that are so and limited. Threatened species require a willing notice at all. Technonator solved this by using AI to analyze millions of recordings, bird songs, human calls, underwater sounds, camera trap images, translating these non-human signals into conservation insights. This is a powerful example of modern human design because, first of all, it embodies multi-stakeholder agency. The, the system considers wildlife ecosystem rangers and policymakers as a part of the design. Second, it demonstrates how non-human data translation turn into a ecological signals to patterns in humans can understand and act upon. Third, it produces symbiotic outcomes. In China, AI helped track the world's remaining pineapple gibbons. In Mexico, charcoal detections increased dramatically. In Kenya, acoustic sensor detected illegal activities earlier, leading to better protection. This case shows how AI and environmental sensing can work together to support biodiversity and human decision making. A real measurable example of modern human UX. Turning into the design principle for modern human UX. This slide summarizes four key design principles. The first one, ecocentric design. Environmental health is placed at the core of every decision. For example, carbon dashboards that surface environmental impact directly in user interfaces. The second one is symbiotic intelligence. Systems designed for humans and AI can learn and adapt together. For example, AI-supported medical diagnosis systems where both parties, the doctor and AI, improve through collaboration. And now, slow design encourages long-term thinking and reflection instead of instant gratification. For instance, interfaces showing long-term ecosystem outcomes better than short-term metrics. And last but not least, post-human ethics expands ethical consideration to non-human lives. For example, the data system that designed to respect animal migration and habitat boundaries. These principles guide designers to move beyond user convenience and toward systemic care. To put these principles into practice, designers need new research methods and tools. Research methods include multi-species ethnography, observing how humans, technology, and non-human abilities interact in real contexts. The next is environmental sensing, using IoT and AI to give voice to environmental conditions, soil quality, water levels, biological behavior. Finally, speculative scenarios. Imagine futures where AI and ecosystems have equal influence in decision making. The design tools also include stakeholder mapping 2.0, expanded maps that include AI agents, environmental systems, and future generations. The second is impact modeling software. Tools like carbon calculators or ecological footprint dashboards can help this. And also the co-design platforms, environments where humans, AI system, and environmental data collaborate together. These methods help designers understand and work within complex ecosystems. Next, this slide explores the tensions and potential of modern human design. The challenges include agency distribution, deciding when AI should override human preference for environmental benefit. The current ethical framework don't fully support this. And then there is also data sustainability. AI systems require huge amount of energy and data. Modern human design must avoid contributing to the problem it's trying to solve. In the challenges lies opportunity include new design roles, positions like ecosystem expert designer or AI ethics officer show how US is expanding. And then there is the regenerative system. The design can move beyond do no harm to actively restore ecosystem through adaptive interfaces and intelligent planning. This shift opens door for more responsible, meaningful design. Looking ahead, some major shifts are predicted. 2030 regulatory frameworks. The global standard may soon require the inclusion of non-human stakeholder rights in the digital system. There is also 60% market shift. A significant portion of companies are expected to adopt eco-centric design metrics. Lastly, new professional identity. UX designer will evolve into ecosystem facilitators, mediating and relationships between humans, their systems, and the environment. Designers must prepare for disciplinary literacy, ecology, and ethics, system thinking, comfort with ambiguity in multi-dimensional decision making. And then there is so technical fluency in environmental sensing, plus advocacy for stakeholders that cannot speak for themselves. This is a radical expansion of what UX design means.